Today going to continue our lecture on part 2, chapter 2 part 2, which is on the sustainable construction, sustainable design and delivery. The table content for today's lecture is on the introduction on the sustainable design and delivery, which is on the sustainable construction concepts, advantages and disadvantages, sustainable construction elements of sustainable design and the principles of sustainable design, sustainable construction regulation and tools, and also sustainable construction techniques, which we will cover on the constructability. VE, value engineering, lean concrete and BIM will be covered on the part 3 next week. Okay, sustainable construction concept, actually we have cradle to grave and also cradle to cradle. I've mentioned this last week. Okay, cradle to grave means that this is the recycle of the building products, which is from the resources extraction, manufacturing, construction, occupancy and maintenance, and lastly demolition and disposal. So when we dispose, means it's go to the grave. Bila kita buang tu kan, kita dah kuburkan dia. Okay, that's why the concept is cradle to grave, from the resources to the grave. However, in sustainable construction design, we want to have this new formula, which is cradle to cradle concept, which actually the disposal will be recycled and reused and become the resources for the manufacturing. Okay, yang bahan-bahan yang terbuang tu, disposal daripada akhir produk kita tu, kita nak guna balik. Kita nak recycle, kita nak reuse, and we want it to become part of the resources to actually start up the manufacturing process for our building products. Maksudnya kita guna balik sebagai sumber. Jadi nampak tak dia punya konsep cradle to cradle, pusing balik, tak ada yang terbuang. Kalau yang cradle to grave ni, kita last kali kita akan ada banyak lebihan sisa sampah. Okay, itu yang dia tidak sustainable lah, tak lestari. So this is actually the example of the sustainable concepts for the cradle to cradle. Maksudnya we have design for assembly, where we have enhanced the ability of adaptation to a variety uses over time. Materials have defined intended pathways and are beneficial to the environment. Kita ada cahaya matahari, develop for well-being, enhance the air quality, integrate topsoil production and carbon reuse, active support biodiversity, enhance water quality, celebrate conceptual and cultural diversity, enhance stakeholders' well-being. Materials have defined content and are safe, optimize the water management, integrate renewable energy, and also we have circularity passport, support material reuse, means that all been recycled back from the cradle to cradle. This is a task for your assignment. I want you to do it in pair, berkumpulan, 2 orang. I want you to find a video YouTube to understand more on the cradle to grave and also cradle to cradle. Okay, but the concept is relates to construction. Okay, so you need to submit a description on the cradle to cradle treatment on the construction materials or resources. One example. Okay, write a history of its life from beginning to end using timeline format. From this number 2, when you had described, write an alternate history for it using the cradle to cradle ideology. Okay, so one example for construction. All right, we go to sustainable construction. In sustainable construction, we have this element in design, which is building envelope, site, building oriented, HVAC system, heat, ventilation, and air conditioning system, energy, water, future of the planet. So this is the element of the design concern. In building envelope, for example, the sustainable building approach can be done by choosing structure and enclosure that minimize energy loss and maximize thermal barrier. So how you want to maximize thermal barrier, how you want to eliminate thermal bridges, okay? Inside, we can actually have many sustainable building approach. For example, we can choose an energy efficient location, inventory existing vegetation, place building with less impact possible to the site. Any trees that must be removed, either recycled to a local mill or chip, or can be used as mulching on site. Recycle all construction waste, provide for different bins for material scraps, and also for the materials that can be recycling. And also landscape with native plants. Okay, no more lawns means that no more maintenance. Tak payah dah nak potong-potong rumput lagi. Kita natural je. Kita letak pokok-pokok kat situ, dia naturally macam tu. For building orientation on site, sustainable approach can be done by capturing the natural energy. Okay, for passive solar heat, breezes, views and daylights, block noise pollution, and major roof area for face south. Okay, so means that we have a green roof. Okay, means we using the building orientation to get everything naturally. Daripada struktur bangunan tu, kita dapat cahaya matahari waktu siang, tak perlu on lampu, kita dapat udara, tak perlu on kipas, macam tu. Maksudnya semua tu menggunakan natural resources. And then HVAC system use system that heat and cool mass rather than air, geothermal or radiant, floor or baseboard, for example. Means that kita cuba dapatkan we use the minimum resources as possible from the utilities, daripada elektrik apa semua kita guna paling sikit. We use more to the natural resources. And then kita guna solar. For energy, design to reduce loads, low voltage light, day lightning. Tu sekarang kita pakai, kalau dekat kebanyakan saya tengok dekat Malaysia, kita dah start pakai lampu solar dekat tepi jalan. Okay, because we have a very high temperature. Kita panas kan, siang panas. Jadi kenapa kita nak bazirkan benda tu? Cuma TNB lah, nanti dah tak ada bil, dah tak ada orang bayar bil. Sebab setiap, for your information, lampu jalan kita tu dibayar, kita bayar. For example, kalau misalnya lampu jalan tu milik JKR bayar bil dekat TNB. So bayangkan kalau dah guna lampu solar, dah tak ada bil lah. Dah TNB tak ada duit lah. Water potable grey black. Okay, for water, we actually design to recycle back the water. Okay, for example, design grey water system. Grey water tu tahu tak air apa? Grey water is from the kitchen, daripada sinki, dapur, pantry apa semua tu, that is grey water. Air tu air dah tak sesuai untuk diminum, but it can be used for watering the plant, siram pokok. Contoh yang kita nak buat dekat dalam masjid UTHM, the grey water from the wuduk. Air daripada wuduk tu kita nak recycle balik guna untuk siram pokok. We can actually doing sustainable building approach by building durable as the goal. As if you're building a cathedral, maksudnya kita nak ketahanan bangunan tu. Maksudnya dia tidak memberi impact kepada alam sekitar, tapi dia bertahan, memberi keselesaan kepada manusia dan juga kepada alam sekitar. Tak ada bagi impact pada alam sekitar. Durability, tahan. Design yang baru tu yang bakteria dalam simen, konkrit. So we have this healing building. So we have the building that can heal by itself. So when the structure crack, so it will actually contact with air and water. So the bacteria will live. Dia akan hidup and the bacteria will heal the crack. Jadi dinding tu akan bercantum sendiri. Dia macam luka lah. Bila luka dia terbelah kan. Nah, kita kan platelet, white platelet dalam badan kita yang akan bekerja dan sembuhkan balik luka tu. Sembuhkan scar tu. Tapi ni dia guna bakteria dalam konkrit untuk sembuhkan balik konkrit tu. Nanti bayangkan bangunan yang hidup, durable, tahan. Bila crack je, luka sikit dinding tu, dia akan sembuh balik. Takutlah pula macam hantu, macam bangunan berhantu lah pula. But that is the new technology that have been built recently. And then use biological filters, use only non-toxic materials, reduce consumption of materials, replant trees equal to the amount of lumber consumed, use natural resources no faster than their own rate of regeneration. Maksudnya macam kita kan banyak sekarang ni ambil natural resources, tak sempat dia nak refill balik, kita ambil lebih. Tapi in the future of the planet, we want to make it, maksudnya kita ambil tapi dia ada masa untuk refill dan dia ada banyak tu je, tak adalah terkurang. Okay, pokok-pokok yang kita tebang, kita nak pastikan kita replace the trees that been cut down. For now, we had deforest in many places in Malaysia, for example, memang dah banyak deforest lah. Okay, maksudnya kita tak tanam balik pokok yang kita tebang. So that's why in UTHM, we have this campaign, 1 juta pokok, 1 million trees will be planted in UTHM. Do you know that? We have this campaign started already. Kita dah start hari tu, awal bulan hari tu. Okay. So how sustainable design construction approach could impact each of the sustainable pillar? So we have this benefits of sustainable design in seating, water efficiency, energy efficiency, materials and resources, indoor environmental quality, commissionings, operations and maintenance, which actually give impact to the economic, society and also environment. So all the design ni kita kena design supaya give a good impact to the economic, society and environment to have the sustainable design. And IDP can assist in achieving design synergies by stimulating interdisciplinary collaboration. The result can be green strategies such as those listed in the leftmost column here. This is an example of project being translated into benefits of the building owners and occupants as well as for the global environment. So for example, you can say, I take one example, okay. Reuse existing structure and or materials where possible. So when we use existing structure materials, so we use of new materials is minimized. The use of new materials is minimized, okay? And then use of construction materials also reduced. And go here, it will smaller, equipment reduce, capital cost and replacement and maintenance costs will also reduce. At the same time, will future embodied energy and emission from eventual replacement is reduced. And at the same time also, energy and emission from initial production of materials are also reduced. So by recycling the existing structure or materials, we actually have two benefits, which is production of materials are reduced, and also energy and emission from eventual replacement is reduced. So this will give impact, a good impact to the public and private environmental, social, health and economic benefits. Okay, so you can read it. From the leftmost is the example of the project, and then to the right is the benefit. Specific procurement strategies to ensure sustainable construction requirements are addressed during procurement. For site environment methods to reduce the environmental impact of construction of the project site and surrounding environments are identified during the site and environment design. And during the material selection, we need to identify environmental friendly building materials, as well as harmful and toxic materials that should be avoided. And in waste prevention, methods to reduce and eliminate waste on construction projects are identified. Recycling, we need to identify materials to recycle at each phase of construction, and methods to support the on-site recycling effort. Energy, methods to ensure and improve the building energy performance, reduce energy consumed during construction, and identify opportunities to use renewable energy resources. And building material reuse, we need to identify reuse materials and methods to facilitate the future reuse of a facility, system, equipment, products, and materials. For health and safety, we need to identify methods to improve the quality of life for construction workers identified. And lastly, for indoor environment quality, we need to actually properly execute methods to ensure indoor environmental quality measures during construction are managed. Okay. So this is actually possible implementation of sustainable construction principle. For example, here, look at here, during planning, the possible implementation that can be done during planning is on the material selection, recycling, energy, and also building and material reuse. So we can plan already what materials that we want to use, how we want to recycle, how we want to save the energy, how we want to do the material reuse. Okay. During design, we can actually implement possible implementation on sustainable construction principles on the material selection, waste prevention, recycling, energy, and also building and material reuse. So same goes in construction plus health and safety and also indoor environmental quality. And at the end, when we had done the construction, the facilities management started, actually we also can implement on the recycling and building and material reuse. Same with in the liability period. At the end of the facility management, decommissioning, we can actually implement on the energy and building and material reuse. So along the process in construction project management and facilities management, we can actually have these possibilities in implementation of the sustainable construction principles. This is an example of each possibilities in possible strategies in procurement, site environment, material selection, waste prevention, recycling, energy, building and material reuse, health and safety, and indoor environment quality. So in procurement, how we want to have this sustainable? Because procurement is more on the mechanism which actually provide a solution to the question, how do I get my project built? So we actually plan on the procurement stage to get a sustainable design. Okay. So first, use sustainable procurement. Okay. So this actually helps to ensure value for money and lower operational costs, which actually at the same time protecting the environment and bring us wider societal impact. And the process in sustainable procurement will be on the pre-procurement, which is on the early engagement with the supply chain, with communication of opportunities, which actually allow to identify of the best practice as well as innovative products, materials, and suppliers. Communication of contract opportunities to potential suppliers. B, on the tender specification, which this stage we actually developing a comprehensive design brief with sustainability requirement fully integrated. C, on the pre-qualification, where it used to of appropriate selections criteria, which actually focus on the past contractors, suppliers' performance, but it also help on some aspect of sifting bidders. Okay. And D, on the award stage, all tenders had a set of award criteria that included sustainability and were evaluated on the basis of most economically advantageous tender. And lastly, on the contract stage, which is contract requirement, including detailed sustainability requirement, for example, GBI. And then on the site or environment element, we need to actually shift off excavated and prefabricated part where the transportation from truck to railway, because truck will produce gas emission, okay, and 90% of or more avoided truck kilometers by using railway. So angkut barang pakai railway tak ada gas emission, kita dah kurangkan pencemaran udara. And for material selection, use locally available material, building material components and system found locally or regionally, saving energy and resources in transportation on the project site. So because it's found locally, kita tak payah nak transport daripada luar masuk dalam dekat site kita. And also buy less toxic building materials. In waste prevention, design for durability and adaptability. Durability, tak ada dah nanti waste. Sebab benda tu bertahan selamanya. Durable. Design for disassembly. Building that can be altered easily or more likely to be renovated than torn down and replaced. Biasanya kita buat macam tu kan. Dekat Malaysia kita buang, kita ganti je yang baru. Bila kita buang, when we torn down, we actually create the disposal. Kita create waste. Okay. Jadi yang tu yang kita tak nak. Jadi kita nak supaya benda tu boleh diguna balik. We can alter, we can refurbish, kita boleh buat balik anything that can be reused or recycled. And then use IBS, Industrialized Building System. Okay, for recycling, construction waste recycling is the separation and recycling of recoverable waste material generated during construction and remodeling. Jadi memang actually memang banyak waste construction. The fact that 3,628 kilogram of waste are typically thrown in the landfill during construction. Banyak tak? Ini memang di mana-mana pun macam tu. Sebab kita tak, we have not fully recycle our construction waste. So that's why everything had been thrown to the landfill. And as I mentioned last week, when we had done this survey in Aitam, Keluang, Parit Raja, we found out that so many illegal dumping construction waste. Sebab dah banyak sangat waste, nak buang kena bayar, pergi hantar dekat landfill kena bayar. So what the contractor did is just throw away illegally. Buang je macam tu. So we need to actually stop this dengan buat recycling. And then use on-site separation. Look at here, dia ada block container ni for the different materials. For example, concrete satu tong, kayu satu tong, plastik dan sebagainya, so that we can recycle. In real life, dekat site dekat Malaysia campur je semua. Dia ada satu yard untuk letak waste, langguk lah kat situ. That's why when our student want to do a research on the waste separation ni dia nak asingkan sisa. Sebab kita campur. Dekat rumah pun macam tu kan. Semua sisa kita campur je. We put everything in one bin. Okay. So in Malaysia still at construction, we did the same thing. We put everything in one bin. So when our student want to do this waste separation at construction, it's very difficult because we dealing with a very big waste. Sisa tu besar-besar, macam mana orang nak asingkan tu, kena ada sistematik lah. Kena ada satu kaedah yang lebih sistematik. It cannot be done alone. Kena ada satu management untuk bila ada contohnya batu-bata, longkok satu tempat asingkan. So it start with separating the waste, then we will work out how we want to recycle it. Energy efficiency can be maximized by utilizing materials and systems that meet the following criteria. For example, the materials, components, and systems that reduce energy consumption in building and facilities. Use low volatile organic compound paints. Okay. Energy Star yang tak ada toxic, dia ada tu. Building and material reuse. Many materials can be salvaged from demolition and renovation sites and sold, donate, stored for later use or reuse on the current project. So typically these materials that can be reused is plumbing fixtures, brick, ceilings, floor tiles, wood. Sekarang ni dekat kalau dekat kilang-kilang, dia buat dia punya showroom untuk floor tiles is using recycled floor tiles. And it's nice. Saya pergi dekat satu kilang tiles dekat Kluang. The showroom is actually all the recycled tiles. Tapi kita tak perasan pun. Kalau yang tak pakar, tak perasan pun, tak nampak pun sebenarnya dia ada macam sengit-sengit sikit, apa semua nampak ada rosak-rosak lah sikit sebenarnya. Why they use recycle tiles? To promote the recycle. Nak promote supaya tile yang rosak ni sebenarnya boleh digunakan masih cantik. Okay. Health and safety. Protecting worker safety and health is sustainable. So we have this rating system for health and safety. And indoor environment quality. To particulate materials such as dust and fibers are likely to be produced during construction and renovation activities. So we have to assure that construction renovation workers are equipped with any necessary personal protection equipment such as PPE, glove, eyewear. Okay. So other strategies you can read further on UK government strategy for sustainable construction. Boleh baca kat sini. Perspective of those strategies, okay, in sustainable, we have actually can implement before, during, after and throughout construction project life cycle sepanjang masa. Yang tadi kita tengok yang dalam dia punya cycle ni untuk construction project management and facilities management. So all these can be done before, during, after. So throughout the construction project management and also facilities management. And several strategies towards sustainable construction. We have actually 4 strategies, which is on the BIM, Building Information Modeling, constructability, value management, and also lean construction. Okay. Constructability, what is constructability? Constructability is actually the capability of a design to be construct. Capable or not, the design be construct. One of the project management technique for reviewing construction process from start to finish during the design or pre-construction phase. So before we start construction, we do the constructability. Jangan dah buat baru kita nak tahu boleh buat ke tak ni. Dah tengah buat tu baru cakap Allah tak boleh buat. So constructability means kita tengok ke boleh pembinaan tu. Capability of the constructability. It will actually identify obstacles before a project is actually built to reduce or prevent errors, delay, cost overruns and wastage. And also one of the sustainable construction that can be implemented within constructability will get better outcomes. So
Constructability or buildability is a project management technique to review construction processes from start to finish during pre-construction phase. It is to identify obstacles before a project is actually built to reduce or prevent errors, delays, and cost overruns. The term constructability defines the ease and efficiency with which structures can be built. The more constructible a structure is, the more economical it will be. Constructability is in part a reflection of the quality of the design documents. That is, if the design documents are difficult to understand and interpret, the project will be difficult to build. The term refers to the extent to which the design of the building facilities of construction, subject to the overall requirements for the completed building, area definition. The effective and timely integration of construction knowledge into the conceptual planning, design, construction, and field operations of a project to achieve the overall project objectives in the best possible time and accuracy at the most cost-effective levels. Key definition. The integration of construction knowledge in the project delivery process and balancing the various project and environmental constraints to achieve the project goals and building performance at the optimal level. See a definition. There are 12 principles of constructability which are mapped onto the procurement process. 1. Integration. 2. Construction knowledge. 3. Team skills. 4. Corporate objectives. 5. Available resources. 6. External factors. 7. Program. 8. Construction methodology. 9. Accessibility. 10. Specifications. 11. Construction innovation. 12. Feedback.
kita tengok lagi satu yang ni.
This video will explain constructability in 3 minutes. Are you ready? Well, come on then. Let's go. Remember Dave? Dave's a project manager on a large construction project. Dave's attending a portfolio update meeting this morning and learns that another project that his company is currently struggling with is 25% over budget and is currently 3 months behind schedule. In doing a project root cause analysis into the reasons for such poor performance, it was determined that many of the challenges that construction faced in the field could have been eliminated or mitigated during engineering design. Julia, the construction manager, and Mark, the engineering manager, both blamed each other for the poor project performance. Dave realized that the engineering, procurement, and construction teams had a poor relationship on this project, with each group existing as a silo. The contracting strategy that was used on the project brought construction in so late that the construction team did not have any opportunity to provide input into engineering design. Engineering invited construction to the 60 and 90% model reviews, but constructability is an ongoing process, and it's difficult to get good construction input in only a couple of meetings. And when construction came up with an idea of the 90% review, engineering said it was too late to change the design. No one appointed a construction subject matter expert to work with the engineering team to identify and mitigate construction roadblocks. Yet, the team said they did constructability. Poor Dave. Dave understands that proper constructability involves the integration of full-time construction knowledge and expertise throughout the project lifecycle, beginning in preliminary planning and design. Dave explains to his team that project cost influence decreases rapidly through the project lifecycle. As construction costs increase, the ability to reduce project cost declines as it's too late to implement many great constructability initiatives. Constructability experts are construction tradespeople that have actual hands-on construction experience. These individuals also have extensive supervisory and management experience that enables them to see potential roadblocks and issues that others would miss. The team works together to define the optimal path of construction and aligns the path of engineering to facilitate construction sequencing. Dave's construction experts use Bentley's ConstructSim platform to review the design and plan sequencing within each construction work area and identify roadblocks and design improvements that could improve construction performance. Constructability efforts allow you to optimize engineering design to minimize construction work done on site and allow you to ensure that work done on site is safe and efficient. This includes improving field build locations, kitting studs, nuts, gaskets, and insulation of module interconnect locations, and leveraging rope access personnel to minimize scaffold costs. On Dave's current project, the constructability team identified an opportunity to build all project scaffolds on the modules in the module yard and ship the modules to site with the scaffolds already built. This initiative reduced scaffold costs, reduced access challenges of over-scaffolding site areas, and had workers completing activities in a safer environment. Dave and his team have proven that early and continued investment in constructability initiatives reduces construction costs, reduces schedule durations, improves safety performance, and makes everyone happier. Another great project initiative, Dave. If you keep performing this well, that promotion will be coming sooner than you think.
Means that constructability kita dah buat lagi, kita dah cuba dulu, kita buat modul, kita dah check. Kita adalah macam kalau conventional method what we did, kita buat, barulah kita tahu oh tak boleh buat, benda ni fail apa semua. But constructability, we have the module. Okay, kita contohnya nak buat tower tinggi mana, kita dah check gegaran dia berapa, dah ada modul kita sendiri. So that is constructability. We actually review dulu projek tu. Cuba dulu kita buat berguna simulasi, modul dan sebagainya, baru kita buat real life construction tu. Waktu simulasi tu, kita buat modul tu, kita dapat tengok apa masalah dia, macam mana nak selesaikan dan sebagainya. On other parts, on the VE value and also on the lean method will be discuss next week. Minggu depan kita akan discuss part 3, chapter 2 part 3.